Hey everyone, and welcome to the channel. I'm Tanya, and as a nurse, I know firsthand how challenging it can be to navigate the world of ADHD. We're always looking for answers, for ways to support our kids, and for information that's both reliable and easy to understand. Today, we're diving into some truly cutting-edge research that's shedding new light on ADHD, looking beyond the usual suspects and into areas that might surprise you. We're talking about connections that start deep within the body and can have a profound impact on our children's brains and behaviors. Can your child's gut, birth type, or even early antibiotics affect their chances of getting ADHD? Science says yes. We're going to explore how the microscopic world inside us, the way our children enter the world, and even the nutrients they get or don't get can play a significant role. It's fascinating. It's a bit complex, but I promise we'll break it all down. In this video, we'll break down 8 surprising ADHD triggers every parent should know, backed by real studies, and explained in a way even 8th graders can understand. We'll look at the science, discuss what it means for our families, and empower you with knowledge, because understanding these hidden factors is the first step towards finding new ways to help our kids thrive. So, grab a notepad, get comfortable, and let's explore these connections together. All right, let's kick things off with our first surprising trigger, the gut microbiome and its link to the brain's reward system. Our gut is home to trillions of microorganisms, bacteria, fungi, viruses, collectively known as the gut microbiome. This ecosystem doesn't just help with digestion, it's in constant communication with our brain through something called the gut-brain axis. This two-way street influences everything from our mood to our cognitive functions and, yes, potentially ADHD. Researchers took a close look at the gut bacteria profiles of children diagnosed with ADHD and compared them to children without the condition. What they found was a noticeable difference in the types and amounts of certain bacteria. Specific bacterial species were found to be more prevalent in the kids with ADHD. These particular bacteria, found in higher quantities in the children with ADHD, are known to produce a chemical that our bodies can then convert into dopamine. Despite the gut bacteria potentially contributing to more dopamine precursor, the researchers observed something seemingly contradictory when they looked at brain activity. Using brain imaging techniques, they found that these same children with ADHD actually showed less activity in key areas of the brain's reward center. This reduced sensitivity in the reward pathways is a critical piece of the puzzle. If their brain's reward system isn't as responsive, it can make it significantly harder for them to feel internally motivated. This isn't about a lack of willpower or not trying hard enough. It's a potential biological difference in how their brain processes rewards and motivation. And incredibly, this difference might have roots starting all the way down in their gut environment. Understanding this intricate link between specific gut bacteria, dopamine pathways, and the brain's reward sensitivity opens up a whole new perspective on ADHD. And that, for parents and researchers alike, is a very important clue. Following on from our discussion about the gut microbiome, it's natural to wonder if we can influence these internal ecosystems for the better. This brings us to our second point, the potential role of probiotics in helping with ADHD. Probiotics, as many of you know, are live microorganisms, often called friendly bacteria, that, when administered in adequate amounts, can confer a health benefit on the host. The idea is pretty straightforward. If an imbalance in gut bacteria, sometimes called dysbiosis, is linked to ADHD symptoms, then could introducing beneficial bacteria help restore some balance and, in turn, alleviate some of those symptoms? Several studies have started to explore this very question, focusing on specific strains of probiotics. For instance, studies investigating the effects of supplementing with these specific probiotic strains in children with ADHD have reported improvements in certain behavioral aspects. Parents and teachers have noted that some children seemed calmer, less hyperactive, and better able to focus after a period of probiotic supplementation. While the research into probiotics and ADHD is still in its relatively early stages compared to other interventions, the initial results are encouraging enough to suggest this is a valuable avenue for further exploration. It underscores the importance of that gut-brain connection we talked about earlier. Let's move on to another crucial element that ties into both brain health and our gut microbiome: omega-3 fatty acids. You've probably heard about omega-3 fatty acids. They're those essential fats, often highlighted for their brain-boosting properties, commonly found in foods like fatty fish, salmon, mackerel, sardines, flax seeds, and walnuts. Now, here's a consistent finding in ADHD research. Children with ADHD often show lower levels of these crucial omega-3 fatty acids compared to their peers without the condition. Given how vital omega-3 fatty acids are for things like attention, cognitive processing, and mood regulation, all areas where children with ADHD can struggle, this deficiency is a significant point of interest for researchers and clinicians alike. It's not just about consuming omega-3 fatty acids, it's also about how effectively our body can absorb and utilize them. Certain types of gut bacteria can influence the absorption of fats, including these beneficial omega-3 fatty acids. Therefore, addressing gut health could be a foundational step in ensuring that the brain receives an adequate supply of essential nutrients like omega-3 fatty acids. It's a synergistic relationship. A healthy gut helps the brain get its building blocks. Next up, let's talk about the vibrant powerhouses found in many plant-based foods, polyphenols. These are naturally occurring compounds found abundantly in colorful fruits like blueberries, strawberries, and raspberries, as well as in vegetables like spinach and broccoli, and even in things like dark chocolate and green tea. Research is increasingly showing that polyphenols can have some pretty remarkable benefits for brain health. Several studies have investigated the impact of polyphenol-rich diets or specific polyphenol extracts on cognitive function and behavior, including in the context of ADHD. The findings suggest that these compounds can exert a calming influence on the brain and may even offer protection against certain types of neurological stress. Incorporating more polyphenol-rich foods into a child's diet is generally a safe and healthy strategy that can offer broad benefits beyond just ADHD. While more research is always needed to pinpoint exact dosages and the most effective types of polyphenols, the existing evidence strongly supports the idea that a diet abundant in these plant protectors is a smart move for brain health and could be a helpful complementary approach for managing ADHD symptoms. Let's shift our focus now to a factor that begins even before birth: vitamin D levels during pregnancy. Vitamin D, often called the sunshine vitamin because our bodies can produce it when our skin is exposed to sunlight, plays a crucial role in many bodily functions, including bone health, immune system regulation, and, importantly for our discussion, brain development. Several large-scale observational studies have explored the relationship between a mother's vitamin D status during pregnancy and the neurodevelopmental outcomes of her child. The findings from some of these studies have been quite striking. They've indicated that when expectant mothers had higher, healthier levels of vitamin D circulating in their blood during pregnancy, their children appeared to have a statistically lower risk of developing ADHD later in childhood. Ensuring adequate vitamin D levels before and during pregnancy as part of overall good prenatal nutrition and care could be one of many factors that contribute to a reduced risk of neurodevelopmental challenges. It's a reminder that the foundations for a child's health, including their brain health, are laid down very early, making prenatal wellness incredibly important. As always, any concerns about vitamin D levels or supplementation should be discussed with a healthcare provider. Our sixth point delves into the very beginning of a child's life outside the womb, the mode of birth. Specifically, we're looking at research that has examined a potential link between cesarean section births and a slightly increased risk of ADHD. A massive study, often referred to as a meta-analysis, which pools data from many individual studies to get a more robust picture, investigated this connection. By analyzing data from a very large number of births and subsequent child health records, researchers found a statistically significant, albeit modest, association. Children born via C-section appeared to have a slightly higher likelihood of being diagnosed with ADHD compared to those born vaginally. The leading hypothesis centers on the initial colonization of the baby's gut microbiome. During a vaginal birth, as the baby passes through the birth canal, they are exposed to a rich and diverse array of maternal, vaginal, and fecal bacteria. Babies born via C-section, however, bypass this journey through the birth canal, resulting in a different initial microbial profile in their gut compared to vaginally born infants. Understanding these connections helps us build a more complete picture. Continuing with factors in early life, our seventh point looks at the use of antibiotics. either by the mother during pregnancy or by the child in their first couple of years, and its potential association with an increased risk of ADHD. Antibiotics are miracle drugs. They save lives by fighting off harmful bacterial infections. However, they are not selective. They can also impact the beneficial bacteria that make up our gut microbiome, and this collateral damage is what researchers are increasingly concerned about, especially during critical developmental windows. Several large epidemiological studies have investigated this link. By examining health records of many children, researchers have found correlations between antibiotic exposure, particularly repeated courses or broad-spectrum antibiotics, during pregnancy or in the first 2 years of life, and a subsequently higher incidence of ADHD diagnosis. The timing seems to be important, as early infancy is a crucial period for the establishment and maturation of the gut microbiome, which, as we know, plays a role in immune system development and gut-brain communication. For parents, this information isn't meant to cause anxiety about past antibiotic use, as many factors contribute to ADHD. Our final point takes us directly into the brain itself, looking at how adolescents with ADHD may process and respond to emotions differently than their peers. Researchers have been using advanced brain scanning techniques like functional magnetic resonance imaging to peek inside the working brain and observe how it reacts to various emotional stimuli, giving us fascinating insights into the neurobiology of ADHD. One area of particular interest has been the brain's response to negative emotions, such as fear, stress, or frustration. Studies using fMRI have presented teens with ADHD and a control group of teens without ADHD with images or scenarios designed to evoke these negative feelings. What they've found is that the brains of adolescents with ADHD can show different patterns of activity in regions known to be involved in emotional processing and regulation, such as the amygdala and parts of the prefrontal cortex. This insight can foster more empathy and inform more effective support strategies. Wow, we've covered a lot of ground today, exploring some truly fascinating and often overlooked factors that science is revealing about ADHD. From the depths of the gut microbiome to the earliest moments of life and the intricate wiring of the brain, it's clear that ADHD is far more complex than just a simple attention problem. These insights give us a much richer, more holistic understanding of what might be contributing to the challenges our kids face, and importantly, they open up new avenues for support and intervention. Science is helping us understand ADHD like never before, from the belly to the brain. It's empowering to know that research is continually uncovering these connections, offering hope and new perspectives. Remember, knowledge is power, and understanding these potential triggers can help us make more informed choices and advocate more effectively for our children. Every child is unique, and what helps one may differ for another. But armed with this information, we can work more closely with healthcare professionals to explore all possibilities. If this video helped you, or if you learned something new that resonated with you, please click that like button, hit subscribe for more content like this, and share it with another parent, a teacher, or anyone you care about who might benefit from this information. Let's keep the conversation going and support each other on this journey.